Welcome to Brain Vision.
In this problem, for part A, we're trying to find the free body diagram for both the hanging block and the block on the table. This is how I set up my system, with the positive x direction being to the left and the positive y direction being downward. So if we draw the hanging block here as a point source, then downward is mg, and upward we have the tension of the rope. And those are the only two forces on the hanging block. Now, as far as the block on the table goes, we have a normal force up, a force down equal to 4g because the mass of the block on the table is 4 kilograms, and we have the tension to the left. Now for part B, our goal is to find the acceleration of either block. And to do this, I'm going to apply the sum of the forces in the x direction is equal to mass times acceleration in the x direction for the table block. And so the sum of the forces is equal to the tension, which is positive because it's to the left, and that's how I define my coordinate system. And then that's the only horizontal force, so this is just equal to the mass times acceleration in the x direction. This yields A is equal to t over 4. At this point, I'm just taking the magnitude of the vectors here. And then we're given t as 15. So this simplifies to 3.75 meters per second squared. In part C, our goal is to find the mass of the hanging block. And to start by doing this, we're going to write out Newton's second law in the y direction for the hanging block. This implies that positive mg, because it's downward and that's how I define my coordinate system, minus tension, because tension is upward, and this is equal to the mass of the hanging block times the acceleration of the hanging block. And this acceleration is the same as 3.75, because when one block accelerates, the other follows its lead. And so we can solve this for the mass. And when we do that, we get the mass is equal to the tension over g minus a. And then plugging in the values for g, a, and t, we get that this is 2.48 kilograms. Now for part D, we need to figure out how the weight of the hanging block compares with the tension. And so the weight of the hanging block is equal to m times g, where m is the mass of the hanging block. We found that in the previous part to be 2.48 kilograms. So we're going to multiply this by 9.8 to get 24.3 newtons. Tension was given to us as 15 newtons. So the weight of hanging block is greater than the tension, meaning that the block will fall to the floor. And that's the end of the problem.